we continue the trends in the properties of the p block elements. The first property that we have discussed is electronic configuration and oxidation state. Now we move on to the metallic character. So what is this metallic character? So losing an electron is being called as electropositive character. Or metallic character, right? So an element, an atom will lose an electron to form a cation, and that property is being called as the electropositive character or metallic character, right? This is the character that we are going to see. So as far as the first 13th group is concerned, so in the 13th group, boron is mostly a metalloid, whereas aluminum, gallium, indium, thallium, these are all metals, right? The metallic character increases on going down the group, whereas in the 14th group, the metallic character here also increases down the group because the atomic size increases and the ability to give the electron also increases, and in this carbon is non-metal, right? And silicon and germanium are metalloids, and tin and lead are metals, right? So first non-metal, then partially metal, then completely metal. Then 15th group, oxygen and nitrogen and phosphorus are non-metals, right? Whereas arsenic and antimony are metalloids, and bismuth is the only metal. This is a metal. And if you take 16th group, oxygen and sulfur are non-metals, right? They are non-metals. And even selenium, oxygen, sulfur and selenium are non-metals. Tellurium is the metalloid, and astatine, polonium is the metal, right? That is the 16th group. Here also the metallic property increases on going down the group. And if you take 17th group, all of them are non-metals. Fluorine, chlorine, bromine, iodine, astatine are non-metals. Even 18th group, it is completely non-metals. There is no metallic property at all in 17th group and 18th group. Because of the electronic configuration, they are unable to give electron, they can only take electron because their electronic configuration is completely filled. Because the electronic configuration is completely filled, losing electron is difficult in 18th group, and in the 17th group they can get only electron, they cannot lose electron. So losing electron is completely ruled out in 17th and 18th. Therefore metallic character will not be there in 17th and 18th. So this is the common trend that we see in the p block as far as the third property is being concerned. And the third one is ionization enthalpy. So what is ionization enthalpy? Ionization enthalpy is the energy needed to remove the valency electron, the outermost electron, right? So I am going down the group, ionization energy is found to be decreasing. Why? Because down the group atomic size increases, right? For example, if you take boron will have only 2 orbits, whereas aluminum will have 3 orbits, and gallium will have 4 orbits. So as the number of orbit is increasing, what is happening? So this is 1, 2, 3, 4. So when the electron is going away from the nucleus, it is easy to remove the electron when it go down the group. Therefore, ionization enthalpy or ionization energy down the group is always found to be decreasing as it becomes easy to remove the electron, right? So this is what that's being observed, right? So however, in the 13th group, when the decrease is not found to be so much when you go from aluminum to gallium. So aluminum to gallium, there is a slight difference, right? So in the aluminum, its atomic number is 11. Therefore, it's 1s2, 2s2, 2p, 6, 3s2, 3p1. Whereas gallium, it is 31. So it's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4s1, 4s2, 3d10, 4p1. So this is how it goes, right? So we got 2, 4, plus 6, 10, 20, 30, 31. Because of the d electrons, right? Wherever the d electron is coming, it has got poor shielding. When it is poor shielding, then the effective nuclear charge will be more on the outermost electron. Therefore, whatever aluminum 13 protons are extracting on 3p1, the same amount of energy, same amount of attraction is also experienced here also, and due to that, it is found that the ionization enthalpy does not much vary when you go from aluminum to gallium. The same type of problem is arriving here also, but here it is being solved because of the excess of electrons that are present from 15th group, 16th group and 17th and 18th group, right? And the fourth property that we are taking up is electronegativity. So what is electronegativity? It is the capacity to attract shared pair of electrons present in the bonds. So it is the capacity to attract the shared pair of electrons or the bonding electrons. This is also, if you take any group, when you go from top to bottom, the electronegativity value is found to be decreasing because the atomic size is increasing. The atomic size is increasing, therefore the electronegativity is decreasing. So far we have discussed about four properties. First is electronic configuration and oxidation state, and the second one is the metallic character. The third one is ionization enthalpy, and the fourth one is electronegativity. And the fifth one is anomalous behavior of first element. Right? What is this anomalous behavior of first element? Right? இப்போ 13th குரூப்ல பார்த்தோம்னா எதனா first element ஒவ்வொரு குரூப்லயும், இந்த குரூப்ல போரான், இந்த குரூப்ல கார்பன், இந்த குரூப்ல நைட்ரஜன், இந்த குரூப்ல ஆக்சிஜன், இந்த குரூப்ல ஃப்ளூரின், இந்த குரூப்ல நியான். ஸோ இந்த ஃபர்ஸ்ட் எலமெண்ட்ஸ் வந்து மற்ற எலமெண்ட்ல இருந்து எப்படி இருக்குது? They differ. The first element which are present in each group is found to be different. For example, boron in the 13th group, boron is a metalloid. Others are metals. right? So in this 14th group, carbon is a non-metal. Carbon is only non-metal, right? And carbon has the property of combining with number of atoms to form long chain. What that property is called as catenation. Yeah, carbon has the property of catenation. So carbon அப்படியே combine ஆகி போயினே இருக்கும். Right? This property is called catenation. Linking with each other and forming a long chain compound is called catenation. Catenation is observed more in carbon. It decreases in silicon, it further decreases in germanium, it further decreases in tin and lead. Right? In the 15th group, nitrogen differs from other elements because if nitrogen is a non-metal, it forms multiple bonds. So these type of multiple bonds are not observed in phosphorus or arsenic or antimony or bismuth. And nitrogen forms a diatomic molecule. Which is not found in other element. If we go to 16th group, oxygen is different. Oxygen differs. So this also forms a diatomic molecule. Right? And it also forms hydrogen bonding, which no other element forms in that particular group. Right? Then 17th. If you take 17th group, fluorine differs from other elements. It is the strongest oxidizing agent. Right? It forms hydrogen bonding. It is highly reactive. Like that, all the first elements in each group is found to be different from other elements. And what is the reason for that? Why they are differing from other elements? There are three reasons which are observed. The first is their atomic size is small. Right? Their atomic size is very small because boron has got only 2 groups, whereas 2 orbits. This will have 3, 4, 5, 6 orbits. Number of orbits is increasing. And the second one is they have high ionization energy and electronegativity. These two are very high for the first elements which are present in each group. Right? And then the third is very important. The third is the absence of d orbital. Right? Because all the first elements, if you take, they are in the second period. So when they are in the second period, they will have only 2 orbits. So if you take first orbit, it will have 1s. If you take second orbit, it will have 2s and 2p. Only when you have 3 orbits, you will have 3s, 3p, 3d. So 3d will start coming only from aluminum. Only from this line we will get the d orbital coming. In the first line, the elements will have only s orbital and p orbital. There is no d orbital. Therefore, there is no extension of valency. There is no possibility of electron transition from the s and p orbital to d orbital. This is the other reason that why it is not capable of increasing its valency and other things. Right? These are the main 3 reasons which gives the reason for the anomalous behavior of the first element found in the p blocks. Right? So this is the 5th aspect. Then we go to the 6th. So the sixth property in which we are studying the trend is inert pair effect. This inert pair effect is a very important factor. You must know what it is, right? So in the p block, in the outermost, we have ns electrons and np electrons, right? 13th group, it will be s1, s2, p1, then s2, p2, s2, p3, like that, right? Always s will have 2 electrons, this will have 1 to 6. So in the p block, on going down the group, when I go down the group, the ns electrons, the 2 electrons, ns 2 electrons will not take part in bonding. Only the np electrons will take part in bonding. So this will not involve in the chemical reaction, only this will involve. Only np electrons will be actively taking part in the chemical reaction. ns2 electrons will not take part in the reactions. Therefore, this is called inert pair. These 2 electrons are called inert pair because they don't react, don't involve. Because of that, the oxidation state decreases. For example, in boron group, it decreases from +3 to +1. Here it changes from +4 to +2. This is in 13th group, this is in 14th group. In 15th group, it changes from +5 to +3, right? These 2 electrons will not take part in the chemical reaction when you go down the group, because when you go down the group, the ns2 electrons are very much attracted by the nucleus due to the poor shielding of the d electrons. Therefore, this will not be allowed to take part in the reaction. Only np electrons will go and react. So that's called inert pair effect. Therefore, what is inert pair effect? In the p block, when you go down the group, in the valence shell, the ns2 electrons will not take part in bonding. Only np electrons will take part in the bonding. These ns2 electrons are inert in nature, and this effect is being called as inert pair effect. Because of that, the oxidation state down the group will decrease. The last property is allotrophy. So allotrophy is nothing but the existence of the same substance in different physical state, right? For example, oxygen can exist as oxygen as well as it can exist as ozone, right? Carbon can exist in the form of diamond as well as graphite, right? So that's called allotropism, and the property is called allotropism, and the substances are called as allotropies. Almost all the elements, they have different allotropical forms, right? So these are the 7 properties that we have to take care in this particular lesson. And in this particular lessons, we are going to take only the boron group, carbon group alone in this lesson 2, and in lesson 3 we will be taking up the other group of elements, right? The rest of the topics we will start studying about boron compounds in the next class. Okay, so keep studying well, be healthy and stay at home. Don't expose yourself to coronavirus. God bless you.